move on to question 6. So question 6, you have all the different components of the EM EM spectrum. Actually, from one look, you know that A is the visible light. So it is pretty straightforward, that one mark. So yes, visible light. This entire question is really it's just factual, whether you have read the textbook or not. So any of the component along the EM spectrum, that means your gamma ray all the way to the radio wave, they are all having the same speed in vacuum. In vacuum, I must emphasize, they will only have the same speed in vacuum, which is 3 times the 10 to the power of 8. Okay, some careless students would go and put a minus sign here, which is ridiculous. Okay, your speed is never that low. Okay, then after that, the example, you just look up your textbook to see what kind of applications are there. Okay, for your question 7 is your DC circuit. It is pretty straightforward. So on the diagram below, draw a voltmeter. Remember, your voltmeter is like a person hugging onto that component. So if you want to measure the potential difference across this 6 ohm resistor, you just need to put a voltmeter here, hug onto the component that you want to measure. Okay, then after that, you are asked to find the effective resistance between the point X and Y. So between the point X and Y, you have 2 resistors and they are connected in parallel. So use the parallel formula. Be very careful that your left hand side is not R effective but 1 over R effective. So in the end, you need to flip the fraction and you get 2 ohm. Okay, explain the following observation. When switch S is closed, why the current at A1 is larger than A2? So it is quite straightforward. Once you close this, okay, these two become a parallel connection once you close switch S, and so the main current coming from here would have to split into 2, and therefore because of this splitting, A2 will definitely be lower than your A1, or should I say A1 will be greater than A2, because this is like the main current, this is just a branch of the current. So how do you explain? First, you must be able to identify that now your connection is in parallel, and then from here you can say that, oh, the current then, okay, must be split into 2 paths, and therefore the current in A2 is smaller than your A1. You could even, if this is not a 2 mark but a 3 mark, you can even say that your A1 current will be equals to your A2 current plus whatever the current that is flowing through, okay, the 3 ohm resistor. But this is an overkill if it is just 2 mark. Okay, then after that, they are asking you when switch S is open, why the ammeter A1, okay, would decrease. So they are comparing when the switch is initially closed, A1 would have some value. When it is open, then A1's value actually decreases. So when switch S is closed, this is in parallel, right? And you know that when your resistor is in parallel, okay, the effective resistance is actually lower than the either one of it. And the evidence of this observation you can see from your calculation in part B. So when switch S is closed, okay, the effective resistance of these 2 resistance is actually 2 ohm. Initially it was 6 and 3, but once you close switch S, they have a combined effect of just a 2 ohm resistor. So once you switch on switch S, okay, your total resistance of the entire circuit actually dropped. Okay, so I repeat, before switch S is closed, okay, the current will flow this way, right? Go this way and then back to the battery. So effectively, when switch S is open, your resistance of the entire circuit is 6 ohm. But when switch S is closed, okay, these two become parallel connected, and the combined effect of this will give you a resistance of the entire circuit to be equals to 2 ohm. So when this is open, 6 ohm. When this is closed, 2 ohm. Okay, and the question is asking you, okay, my switch S is closed, 2 ohm, So the resistance of the entire circuit is 2 ohm. So because you have a lower resistance, definitely, okay, you will have a stronger current, right? And once this is open, your resistance of the circuit is 6 ohm. So a higher resistance will lead to a lower current, and that's why your A1 would drop. You got it? Okay, if you don't get it, try to rewind on the YouTube video and listen to me again. If you still have problem, what I suggest you to do is write it down. Okay? Okay, since some of you may have difficulty, so switch as on, switch as off. And you have your effective resistance of the whole circuit. So this is one of the learning tricks that I learned in uni. When my professor are starting to, lose me, I would have to write down what he says in a table form and try to make sense out of it. So when S is on, okay, on means it is closed, off means it is open. So when my S is closed, the effective resistance will become 2 ohm. And if it is open, it will be 6 ohm. So this guy is low, this guy is high. So therefore, the main current of the circuit, because the resistance is low, the main current must be high. Okay, and when the resistance is high, my main current will be low. Okay, and the question is asking me when it is closed. Okay, my A1 value is high. When my switch S is open, my A1 value decreases. So it matches with the problem context, and I have explanation. Okay, so now I understood how does this work. So now I need to explain in words. So since it is about comparing two time frame, right? So when S is closed, okay, our effective is equals to 2 ohm. Hence, full stop, hence the current passing through, let's shift here, passing through A1 is high. In fact, I can calculate it. So how do I calculate? V equals to IR. My V is 3 ohm. 3 I get it from the battery, I, and the effective resistance is 2. So I will be able to get I is equals to 1.5 ampere. Okay, full stop. Then I'm comparing, right? And when my S is opened, my R effective is equals to 6 ohm. So hence the current through A1 is lower. In fact, you can again calculate it out using the same method. V equals to IR, 3 equals to I bracket 6. I would be 0.6 ampere. Full stop. So with this passage, basically you would have explained why when the S1 is open, the reading of A1 decreases. So this is why. Okay, let's move on to question 8, electrical conductor, blah 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 blah. Okay, so to explain a current of 4 ampere. So this is a very typical way of asking for definition nowadays in O level. So what you need to do is that you need to give the definition first, and then substitute what you know with the problem context, which is 4 ampere here. So what you need to know in terms of content is that I can be expressed as the amount of electron flowing per unit time. Okay, so you need to have this knowledge first. So once you know that, translate it into English. So you can just say that it means that there are, now since this is 4 ampere, right? So what you are having here is that you have 4 ampere of current. So how do you get 4? 4 over 1, right? So you have 4 coulomb of charge flowing through in 1 second. Okay, so you must be able to express this, okay, using the problem context. So it means that there are 4 coulomb of electrons flowing through in 1 second. Finished. Yeah, so this kind of thing tests whether you can express the derived quantity, which is current, into its basic component. Okay, then after that you are asked to find the potential difference across the conductor. What do they give you? This is the conductor, you have 4 ampere. Oh, okay, they have given you another information, which is joules. Okay, 20 joules. So in 5 seconds. Okay, so what you need to do is that you need to take a step back and try to, okay, one of the common mistakes that students do is that, oh, okay, they look at potential difference, they recognize that, oh, okay, this guy is in volts. And okay, I also remember that I have studied and see this formula before, that V is equals to the amount of work done over the amount of charge. Okay, I know this is the formula. Oh, okay, I see this one work done 20 joules. Okay, let's put in 20 joules. Okay, so far so good. Hey, what is my Q? I don't know what is my Q. Okay, let's put 4 then, since this one says 4 ampere, right? Let's put 4. Since here is also 4 coulomb, right? So I put 4 here. And you will get a wrong answer. Why? Because this 20 joules is in 5 seconds. So this guy here is in 5 seconds. But this 4 ampere is in 1 second. Yeah? So you need to be able to identify that. So in 1 second, you have 4 coulomb of electron. So in 5 seconds, how many coulomb of electron you have is 20 coulombs of electrons. Yeah. So since you are using the work done, okay, in 5 seconds, then therefore your amount of electron must also be in 5 seconds. Okay, the amount of electron here must be in 5 seconds, because this 20 joules is the amount of work done in 5 seconds. So you must standardize that. So down here, you should also have 20. Okay, because of this. So before you do substitution into the formula, okay, go and take a step back and think through, are you using the correct value? Is the unit the same? Okay, then you make a decision. So therefore, your potential difference is just 1 volt. Yeah, okay. Okay, question 9. Question 9 is again about the right hand grip rule. You are asked to draw the direction of the compass. So we have to find out, okay, how the magnetic poles, where is the magnetic poles on the solenoid. So first identify the direction of the current. So it's going this way. So you know that it's going this way, in front of the thing, in front of the thing, in front of the thing. So it goes this way. Yeah. So this is the rod. Okay. This thing is this rod. Right hand grip rule. My fingers will represent the current. So now you see the current in front of the rod is going down. So should I put this way? No, right. My current in front of the rod should be going down. So I should go down, and you can see that where my thumb is pointing is to the right. So you know that this is north, this is south. So north, right? North means that my magnetic field line is going away. So therefore, your compass will go to the right. Okay, the compass will always follow the magnetic field line. Yeah. Then after that, you are supposed to draw the magnetic field line around the soft iron and indicate the direction. Okay. So what do you mean by soft iron? Soft iron is this core. This thing is the soft iron. So very easy, it is like butterfly. So 5 lines, right? First line will be 1, 2, 1, 2. Then just make sure it doesn't cross and it is symmetrical. 2. Oops. Oops. So my era is always liquid paper, so that's how you should do it. Okay. As long as it looks like it is symmetrical, we won't be too picky for this. So this one is going out, so therefore it's going here, it's going here, this guy is going here, this guy is going here. So I have 1, 2, 3, 4. I need one more. So let's draw a smaller one here. Oops. Yeah. Okay. Just make sure your line don't cut across each other. So okay, for symmetry's sake, I'm going to give it one more down here. Okay, as long as it looks like it is symmetrical. So make sure that the starting point or the end point, the magnetic field line are not touching. Okay, and it should look symmetrical. Okay, and always remember it's always going out from the North Pole, going in from the South Pole. Pretty easy paper, right, so far? Okay, question 10. Question 10 is about echoing. I'm going to do all the questions, so don't worry. So they tell you that the speed of sound is 1500. Please remember that the speed of sound is only dependent on the medium that it travels through. And then they tell you about the frequency of the sound. So this is what I usually do. I will just write down the parameter outside. Okay, this one, be very careful of the unit. This is megahertz. So mega is times 10 to the power of 6. Okay. So I will usually write down the parameter. And you are asked to calculate the wavelength. So this one is pretty easy. You just need to know about this formula. Okay, substitute the value that you have. 1005 here. Frequency is in mega. So write it down. Lambda. Use your calculator. Okay, let me get this straight. Yep. You get 0.00227. The unit is wavelength. So the length is the distance, right? So therefore, meter. Okay, if the time interval between the sound and blah blah blah, the echo received is 1.4, calculate the depth. Now this is, be careful, you look at how the sound wave travel. It is going down and going up. And actually what you want to find is just one depth. So if down here, okay, I will do below here where I have some space. Okay, I shouldn't have used pen to draw here. Okay, let me make quickly. Okay, so for your part B, yes, you can just use your average speed formula, which is equals to this, which is this. So you already know the speed, which is 1005. Okay, you also know the time. Okay, the time given here is 1.4, so just put 1.4 here. You'll be able to find the distance that you travel is 2001. Now, if you look at this, the 2001 actually account for going down plus going up. So if you just want to find out the depth of the sea, you must remember to divide the 2001 by 2. Okay, which is 1050 meter. Okay, yeah, some of you has actually asked me, teacher, but the depth is actually the straight line. So shouldn't I use Pythagoras theorem and find this thing? Okay, the thing about this is that this is just an illustration. So we can give a very close approximate, okay, that that this can be interpreted as straight line. Okay, but in actual fact, you are right. If I really want to find just the depth here, I need to use Pythagoras. But in this case, since there's no information given in the wave, you cannot use Pythagoras. Okay, so you do best. I mean, you just try your best with the information that you're given. Okay, explain the difference between longitudinal and a transverse wave. Please refer to your textbook. Okay, I can say on the video that longitudinal wave, okay, it is the particle. Okay, a lot of you will just say that, oh, the wave move back and forth. That's it. Okay, it is not the wave that is being moving. Okay, it is the particles in the wave. Okay, so a longitudinal wave is whereby the particles in the wave are moving parallel to the direction of wave motion. Okay, whenever you mention parallel or perpendicular, you have to give a reference. Parallel to what? Perpendicular to what? So I repeat, longitudinal, the particles are moving parallel to the direction of wave motion. Transverse wave, the particles are moving perpendicular to the wave motion. Okay. Then briefly explain how a sound wave is created and transmitted. Please refer to your textbook. Okay. How do you score? Since they talk about how it is created and transmitted, you have to talk about this in separate points. So sound wave is created by vibration. It is transmitted through a medium, okay, by a series of compression and refraction. Finish. 2 marks. Explain why the sound is greater in water than air. So again, remember, sound is transmitted through vibration in the medium. So when the particles in the mediums are more closely packed, it will make the transmission of vibration quicker and easier. And since your water is closely packed, the particles in the water is more closely packed than that of the air, hence sound can transmit at a faster speed in water. Okay, I will leave the writing to you. Okay,